Hello everyone, welcome back to the channel. In the previous video, we built our very first MCP server using Java, Spring Boot, and Spring AI. We created a simple calculator application and exposed 4 Java methods: add, subtract, multiply, and divide as MCP tools. We also tested those tools using the official MCP inspector and verified that our MCP server was working correctly. However, one important question still remains. How does an AI model like ChatGPT or OpenAI actually use those tools? That's exactly what we're going to build in this video. We'll create an AI client using Spring AI, connect it to OpenAI, and then connect OpenAI to our existing calculator MCP server. By the end of this tutorial, you'll be able to type a natural language question like, use the calculator tool to add 10 and 20. The AI will automatically discover our calculator tool, execute our Java method, and return the result. Let's get started. Let's create a Spring Boot project using Spring Initializer. Select Project Maven and language Java. Spring Boot version 4.1. Enter artifact, Java MCP Client, and select Java version 21. For dependencies, we'll only select Spring Web. Generate the project and open in VS Code. We have manually added the Spring AI dependencies so you clearly understand which libraries are responsible for OpenAI integration and MCP communication. In pom.xml, the first thing we have added is the Spring AI BOM. This manages the versions of all Spring AI libraries so we don't have to specify versions individually. You'll notice that I changed the dependency from Spring Web MVC to Spring Web. The reason is that Spring Boot Starter Web is the standard dependency used for building Spring Boot web applications. In other words, Spring MVC is already included inside the Spring Web Starter. It already includes everything required to build REST APIs. Next, we have added the OpenAI Starter dependency. This dependency allows our application to communicate with OpenAI's API. Finally, we'll add the Spring AI MCP Client Starter. Unlike our previous project, where we built an MCP server, this project acts as an MCP client. Now let's configure our application. First, we have configured our application a name. Next, we have configured the OpenAI API key. This key allows Spring AI to authenticate with OpenAI. After that, configure the MCP client. We have used the streamable HTTP transport and specify the URL of our calculator MCP server. Notice that we're connecting to our existing application running on port 8080. Since both applications cannot use the same port, we'll configure this client application to run on port 8081. Now let's configure the chat client. The chat client is Spring AI's main interface for interacting with language models. We have created a chat config class and define a chat client bean. Here we're also registering the MCP tool callback provider. This is an important step because it allows the chat client to discover all the tools exposed by our calculator MCP server. Without this configuration, OpenAI would never know that our calculator tools exist. Next, let's create a REST controller named Chat Controller. We have injected the chat client that we created earlier. Then we have exposed a GET endpoint called our chat. Whenever a user sends a message, we'll pass that message directly to OpenAI using the chat client. The response generated by OpenAI will simply be returned to the browser. Notice how little code is required. Spring AI handles almost everything for us. Now let's start both projects. This is the Java MCP calculator server that we built in the previous video. If you haven't watched that tutorial yet, I'll leave the link in the description, and also add it in the top right corner of the video. As you can see, our calculator MCP server has started successfully and is now running on port 8080. Now let's start our Java MCP client application. This application will connect to OpenAI as well as our calculator MCP server, acting as the bridge between the AI model and our Java tools. At this point, both applications are up and running. Our Calculator MCP server is running on port 8080. Our Java MCP client is running on port 8081. Now we're ready to test the complete flow. First, let's make sure our Java MCP client is working correctly. I'll open the browser and send a simple request. Add 20 and 10. As you can see, the AI returns 30. But hold on. This doesn't actually prove that our MCP server was used. The AI model already knows that 20 plus 10 equals 30, so it could have calculated the answer itself without ever calling our Calculator MCP server. To verify that the AI is really invoking our Java tool, I temporarily modified the add method. Instead of returning the actual sum, I've changed it to always return 99.99. Now let's send another request, but this time we'll be more explicit. Use the Calculator tool to add 20 and 10. Let's see what happens. Perfect. The AI responds. I used the Calculator tool, but its output was 9,999. This is exactly what we wanted to see. It proves that OpenAI actually invoked our Calculator MCP server and executed our Java method. The reason it also mentions that the correct answer should be 30 is because large language models are designed to be helpful. Let's quickly review the complete flow. The user sends a prompt. The Spring Boot client forwards that prompt to OpenAI. OpenAI analyzes the request and decides whether it needs a tool. If a tool is required, it invokes the Calculator MCP server. The server executes the Java method and returns the result. Finally, OpenAI generates a response using that result. This entire process happens automatically. In the previous video, we learned how to build an MCP server. In this video, we connected that server to OpenAI and enabled automatic AI tool calling. In the next video, we'll build an actual AI-powered application using MCP, where users can interact through a simple chat interface instead of passing messages as URL parameters. If you found this video helpful, don't forget to like the video, subscribe to the channel, and turn on the notification bell so you don't miss the upcoming tutorials.